Okay, continuing our discussion of vector addition by components, we're going to take a look at number 5. So here we have, before the football game, a fan of the opposing football team walks down from his seat on the away side bleachers, continues walking directly across the field, and walks up the home bleachers to the concession stand located at the top. The away bleachers are positioned at an angle of 35 degrees with respect to the football field, and his seat is 15 feet above the ground. The width of the football field plus the sidelines equals 190 feet. The concession stand is located 38 feet high at an angle of 41 degrees with respect to the field. How far does the fan travel from his seat to the concession stand? So we're this first initial part for A, we're just looking for the distance that he travels along his path. So first we need a frame of reference. So we're going to pretend that we are standing in the middle of one of the end zones of the field, looking back at the field. So on one side we have the away team's bleachers, okay, which is where he starts, and then on the other side we have the home team's bleachers. And if we're looking at this from the perspective of from one of the end zones, it's going to look like a triangle. Okay, so we've got the sloped bleachers going down. So that's our first vector, is him walking down from the bleachers. Then I'm going to use green because it's a football field and hopefully their grass is green. And he walks 190 feet that way. And then the home side bleachers, another triangle, and the home stand must be a little bit taller based on what they're talking about. And of course this is where the concessions are. So obviously he's going to get some nachos or something, so he's coming up here to the concession stand, and that's where he ends. So let's take a look and see what all the information that it gave us. Okay, so he started from the away side and continues walking directly across the field. Okay, so the away bleachers are positioned at an angle of 35 degrees with respect to the football field. So with respect to the football field, we have an angle of 35 degrees. Okay? And let's see, and his seat is 15 feet above the ground. So over here we have 15 feet above the ground. Okay, so those are the two pieces of information that it gives us about the away side. Then walks across the field, and it says that the width of the football field plus the sidelines is equal to 190 feet. So once he gets to the bottom of the bleachers, he then walks straight along the field for 190 feet. Okay, and then the home side bleachers are 38 feet high, or the concession stand is at the top where it's 38 feet. Okay, and at an angle of 41 degrees with respect to the field. Okay, so this is how we diagram it out. All right, so what are we looking for? Distance number 1 is going to be right here. So D1 is right there. Is that diagonal path that he took down the bleachers. And so the pieces of information that we know are, we know that it's at a 35-degree angle, and we know that the height is 15 feet, which is opposite that 35-degree angle. Okay, and we're looking for the hypotenuse. So we were given the opposite side and the angle theta, and we are looking for the hypotenuse, which means that we're going to be using the sine function to find that. So the sine of 35 degrees is equal to the opposite side, which is that 15 feet, over the hypotenuse, which is our D1. So that's how you would calculate that. For this problem number 5, I'm just going to get it set up for you. I want you to do the math. Our second distance, our D2, they gave us. Okay, so you don't have to do any calculating at all. You just have to figure out what that D2 is. okay, based on the information that they gave us. Hint, hint, hint. Okay, so that's going to go there. Okay, and then the only other thing that we're going to have to do is we're going to have to calculate what the distance is up the bleachers, this blue line over here, up to the concession stand. And again, we're given the angle, and we're given the value opposite the angle. So our opposite side is 38 feet, and we're looking for the hypotenuse, which is our D3. So our hypotenuse. So again, if we're given the opposite, we're looking for the hypotenuse, we're going to want to use our sine function. So sine of 41 degrees is equal to the opposite side, 38 feet, over the hypotenuse, our D3. Okay, so that, once you calculate it, will go right there. Okay, and then of course your total distance is just going to be the sum of all three of your distances put together. D1 plus D2 plus D3 equals our total distance. So distance 1 plus distance 2 plus distance 3 gives us our distance total. So you need to calculate that once you've found all of the other values. Part B of the problem says, what is the magnitude of the fan's displacement from his seat to the concession stand? Show all the work in the space below and type your answers in the space provided. So if we take a look at our diagram hasn't changed. We're just going to add a few values to it. Okay, so what we're going to do is we're going to diagram out the exact same thing. So they start from the away side, go down to the field, walk across the field, and then walk up to the concession stand. Okay, so we have all of these components. Remember, that's what we're doing here, is vector addition by components. So to figure out the magnitude of displacement, what we're going to do is label everything that we know, just like I always do. Okay, so 100 and what was it again? 190 feet. So we have 190 feet for the field. The away bleachers, his original seat was 15 feet. And the concession stand is 38 feet high. So we've got 15 feet over here. Okay, and then we have 38 feet over here, and then our two angles, we have 35 degrees and 41 degrees. So 35 degrees and 41 degrees. 35 degrees and 41 degrees. Okay, so we're going to break this into the components. So if this is our first vector, the components are going to be d1 and or dx1 and dy1. So dx1 is the x value of our vector, of our first vector, and dy1 is the y value of our first vector. So dy1 they actually gave us. Okay, so that you're just going to plug in there. We have to calculate dx1 using one of our trig functions. Well, let's see. We know the opposite side, and we're looking for the adjacent side. So opposite and adjacent means that we're going to be using tangent. So the tangent of 35 degrees is equal to the opposite side, 15 feet, over the adjacent side, which is our dx1. So once you find that value for dx1, that's what you're going to put in that first spot. Okay? Our dx2, we're given. Okay? So that just goes here. So dx2 is 190 feet. Okay? Our dy2, well, if this is a horizontal line, the y value is, of course, 0. So we have 0 feet. Okay? And then over on the other side, for our dx3 and our dy3, dx3 we're going to need to look for because it's down here. We were not given that information. So our dx3, and that is adjacent to the angle that we were given. So dx3 is going to be our adjacent side. And then we were given the opposite side. Opposite side is equal to 38 feet. So our opposite is 38 feet. Our adjacent side is what we're looking for. We were given an angle measure of 41 degrees. So again, opposite and adjacent, we need to be thinking tangent function. So the tangent of 41 degrees is equal to the opposite side, 38 feet, over the adjacent side, dx3, which is what we're looking for. Once we get that value, that'll get plugged in here. Our dy3, okay, our dy3 is what we were given, so dy3 is 38 feet. I'll even be really nice here and show you that you just plug in the dy1, the 15 feet, right over here. Now, what we have to be careful of is, because we're talking about displacement, remember he went down 15 feet, and over here he's going up 38 feet. So when we say that this displacement is 15 feet, we need to make sure that we say 15 feet down or negative 15 feet. All of the other things that he's doing in the x direction, he's moving to the right, so they're all positive, so that's easy. The one thing that we do need to make sure that we account for is this negative over here, because he's going down the bleachers at first, and then he goes back up the bleachers on the other side. So the dy total we can figure out by adding all three of these values together. Okay, so negative 15 feet plus 0 feet plus 38 feet is a total of 23 feet. Okay, for the dx3, dx2, and dx1, well, we're given the dx2, the 190 feet. We still need to figure out the dx1 and the dx3. Once you solve those from the diagram, once you calculate those from the diagram and then plug those in, then you can get this dx total. And once you have these two values, dx total and dy total, you can figure out the total displacement, okay, or the resulting displacement by using the Pythagorean theorem. So you take the dx total squared, that's plus the dy total squared, and that's going to be equal to the d result, so the resulting displacement squared. And then that's how you're going to be able to calculate the total displacement.